So
Go ahead again.
question 3. Yeah, so of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So confidence interval, known, unknown, or mean differences using dependent samples, or mean differences using independent samples.
Is it the independent one?
So I'm not 100% sure, but I think that because they're not looking for, oh, they are looking for a different, yes, to see if they're different from males and females. So yes, I would say probably independent. Yep.
Okay. All right. So researcher interested in estimating some things. Which of the following would produce a confidence interval with a smaller margin of error than this 95%? You could use a bigger sample size. Let's see what is. Let me see these answers. Than 30.
Sorry, I'm getting confused.
I didn't. What I said was okay. So is that obtain
Oh, sorry.
balances of 90?
Sorry, the questions on the review don't line up exactly with the numbers. Okay,
Okay,
sorry.
sorry.
Yep,
Yeah.
that's
So
fine.
we're on the one that. Did you find it?
Yes.
Okay. So I was saying 90 bank customers rather than 30.
Yeah, that's what I was thinking.
Okay. Now we're doing a factory makes a propeller drive shafts for ships.
Hmm.
And then the question is input your answers for those things. Okay.
Yes, I didn't finish that one yet because I just wasn't sure which formula I was supposed to be using.
Right.
Because my first thought was like x bar minus t, times, but but then I thought we don't have all those numbers, so
Yeah. Let's see. Well, we know the sample mean, standard deviation, and the confidence interval. I think with that much information, we can put it into the Excel thing, right?
which
Or
Excel thing?
perhaps the quantitative inference.
Oh,
Is that right?
oh, probably. I haven't pulled up that one in forever. Not the quantitative inference procedures, but the first one we were using. That's
Right.
possible.
Mean standard. Let's see. Yeah. So the one sample, the sheet for one sample t-test, it has a spot for mean. I'm gonna clear this. So if I put in the mean as 1,000, standard deviation was 2, and do we have a sample size? We don't have a sample size,
No,
right?
no.
That's a problem. Oh, 4 drive shafts? Is that good?
Does it say?
She randomly selects 4 drive shafts.
Oh,
Okay.
yes.
All right. And then the null hypothesis, what would that be? 1,000?
Um, yes, that'd be 1,000. I totally missed that 4 because it's silly. Okay.
Okay, we switch it to not equal to, right?
Mm-hmm.
Okay, so the confidence interval, we can do the upper and lower bounds easy. So it looks like the lower bound is 996.818 for the lower bound, 996.818.
Okay.
And the upper bound, 1,003.182.
1,003.182.
Yeah.
Which Excel document are you using?
I was using the quantitative inference procedures and then just the first page, which is the one sample t-test.
Okay. Okay. And you just input the mean and everything by hand. Yeah.
Yeah. Yeah, and then
Okay.
make sure the variable column A is clear.
Okay. Except for just the one, or no, just all the way clear, right?
Yeah, I can try to.
Okay. No, I got it. Yeah. Thank you.
Okay.
Okay. What about the margin of error?
So the margin of error is just half of the confidence interval. So we could either. So the best way to do it is probably just take the mean and then subtract one of them. So I'll just do an equals 1,000 minus that. So yeah, it's basically just 3.182.
Okay, and you got that by dividing it.
Yeah, it's just one half of the confidence interval. So in this case, since the mean is a nice round number, 1,000, we can pretty easily see that, like, for example, the upper limit would be at 1,003.182. So we know that half of the confidence interval, which is the margin of error, is also 3.182.
Okay.
Yeah, because it's basically like the confidence interval is like the diameter, and then the margin of error is like the radius.
Are you doing a 95% confidence interval?
Yeah.
Because on the lesson review, 1,000, the number that we're using isn't an option. 1,003.182 isn't one of their answers.
Is
They
yours
have a
multiple choice?
1,003.92. Yeah, it's the review was multiple choice.
Oh.
Anyway, just so we know, like if that ends up not being correct, then we can.
Okay. Well, the one thing that might change it, I've set it to not equal to. If I do, let me see if greater than or less than. Yeah, that's not changing anything.
Okay. All right. Well, we'll keep chugging along and see if what it says.
So yours, what it said, 1,003.92.
Yeah, that's the only one that's close to what we're getting, and then the lower bound was that goes with that was 996.080. So they're both really close to our numbers.
Yeah, which makes me feel like we should just put those because it's gonna get marked wrong. I had that problem before.
Okay, good idea. Do those, and then we'll see if yeah. Okay, so 996.080.
Okay, and then the other one.
But I wonder where the heck they got that. 1,003.920.
Okay. And then is there a margin of error that's somewhere around 3 or 2.8 or something?
It doesn't ask for the margin of error.
Okay. I mean, we could like reverse engineer it and figure it out from the numbers you gave, but given our time crunch, I guess we'll let it go.
Yeah, okay.
All right, and the next one is to assess the accuracy of laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weigh-ins is computed. Suppose that the scale readings are normally distributed with unknown mean, a sample mean, and standard deviation. How large should n be so that a 95% confidence interval has sample mean margin of error of 1/10,000?
I guess if we just put in, so these are the numbers they give us. 1960, you know what I'm saying? Like if we put in those numbers into like we've got the standard deviation, we've got the confidence interval, we even have the margin of error, but I don't know if that matters. But they don't give us n.
Yeah.
So can we still do it? But
yeah, and I think like 2 weeks ago we did I got the formula for finding sample size.
Oh. That does sound familiar.
Yeah, let me see if I can pull it up real quick.
The rest of the questions, in my opinion, were not as hard as these ones right here.
Okay.
These are the two I struggled with the most.
Okay, do you want me to read you the sample size formula just so you have it?
Yeah, please.
All right, so I can show it to you in a second too. N equals, and then in parentheses, this whole thing, Z times the standard deviation, and both of those are divided by the margin of error. And then it's closed parentheses on the outside of all that, and then that's squared.
Okay.
Can you see that? Don't know if you can.
Yeah. Yeah, okay. Thank you.
All right. And then...
So then Z would be... What did you say?
Yeah, that's like the Z score.
We have to put it in to get the Z score?
Yeah, that's what my tutor was saying. Yeah, put in the applet, I guess.
2, 1. Okay. Standard deviation is 0.01. And then you said to get the Z score. Okay. Okay, so I don't think they gave us the link for the... Oh, they did. Okay, for the applet. So
I'm okay moving on from this one. I just wanted to make sure I gave you the formula at least.
Yeah, thank you. I just don't remember where we put the information into the applet. Like what we put in there. You know what I'm saying?
Yeah, me neither. To be honest.
Okay.
But at least you have the formula, so that's a head start.
Yes. Fast forward from there. Okay, so what question?
Yes, the next one is the mean.
Yes. So this one's actually just the last part. The appropriate null and alternative hypothesis. They want you to tell. A tenant group thinks that the arguments are smaller than advertised. So what's the right formula?
Would that be the one that has the less than symbol?
Correct.
Okay.
In a statistical test of hypotheses, we say we reject the null hypothesis with the level of significance A if the p-value is larger than A, less than A is small, or A equals 0.05.
Is less than?
Correct. Okay, a group of students get better grades than other students. They collect the GPAs. The data for, this one was a little weird to me. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their questions? Aren't the ANOVA hypothesis tests, aren't they all supposed to be right skewed?
I don't remember that. Yeah. Let's see. 15. It's 15 of 4 different apartment buildings. So I guess, I mean, I'm guessing it would be the central limit theorem answer. Yeah, that's my best guess. Are you there?
Can you hear me now?
Yeah.
Sorry. Okay.
Yeah, so I'll try the central limit theorem answer.
Yeah, it says for ANOVA testing, we use an F distribution, which is right skewed.
Okay.
So anyway, yeah, go ahead and give that a. So I said, oh, where's the done review? What number is that one?
That one was 12. And 13 is talking about a medical researcher.
I don't know why they just couldn't do the same
Right.
questions. Oh, dang it, I've lost where we were. Okay, sorry. Yeah, just.
Yeah,
I
so
guess I should have written the answers.
okay, you go ahead. Cool. So the researcher we're talking about,
So I guess.
they might have used.
Okay, sorry. So yeah, a medical researcher is working on a new treatment. Oh, for the cancer. I know it's in here.
And then
Okay.
my tutor was talking to me about type 1 to type 2 errors.
Yes.
Okay.
Yeah, I've got the errors down. Yeah, I mean, I think I do at least.
Yeah, so type 1 is when they reject something that's true, right?
That's true. Yeah, so A, type 1, or sorry.
Type 1.
Type 1 error. Yeah.
Sounds good.
Okay. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? So when we reduce one, what happens to the, yep, the other one gets bigger. Okay, the nicotine content in cigarettes gives us a standard deviation. The brand advertises. Okay, so this one I was thinking because the sample mean 1.53 is bigger than 1.5 by exactly 0.3. Then I was thinking it's smaller than the level of significance, which is 0.05. Does that make sense?
Yes.
So I'm guessing based on that. I didn't do any calculations. I just thought, oh, 1.5 is exactly 0.03 larger. So if the level of significance is 0.05, then it's smaller than the level of significance, which would mean that we reject the last answer. We would reject the null.
Okay. And there's one that says like reject the. Is that the alternative with the little A down there? Yeah.
No, yeah, that's the alternative, but we want to reject the null, I think.
Sounds good. Okay, you look at the number of hours, random sample 100 hours. What's the correct statistical procedure? Male and female. So a paired t-test?
They're male and female students, yeah, so they're not dependent.
Okay,
so
and
they're either independent sample t-tests or a paired. Do you know the difference?
Yeah. Okay, independent then. Sounds good.
Or it might be paired. I'm not sure, honestly. I think paired is when it's the same. Anyway, let's try independent.
Yeah, paired would be like a woman like before and after getting a college degree or something.
Yes, I think so. Okay,
yeah.
So on educators interested in academic achievement by males and females. Okay, so they just want to know, is this independent? It's just males and females, that's it. Oh, so she decides to use brothers and sisters raised in their same home. So would that be independent or dependent?
Dependent, I guess.
The sampling of brothers and sisters, correct? Because not because the academic achievement depends on the other, but because You select a brother, so as to compare his academic achievement to his sister, you must include the sister in your study.
Okay.
Use the following information to answer the next 4 questions. I'll just tell you what I got.
Okay.
So I just typed these in, to the Excel sheets. So number 18. Okay, this is the dissolved carbon, whatever that means. Okay, so is the first one asking about confidence interval?
Uh-huh.
Or whatever. Okay, so that's 15. So I said B, confidence interval for when it is unknown.
Okay.
I mean, some of these are my best guess, but anyway, 16. Which of the following? I said D, which was 11.909.
They might be out of order right here.
Oh no.
You said 16 you're on?
Yeah, well, for the review.
All right, so it's
Determine the
determine the
margin of
margin of
error.
error. Okay.
Yeah, for the confidence interval. So sorry, yeah, they don't have me do that part. So skip to number 20. What I got was
The lower bound?
the lower bound is D 11.168
Okay. And the upper?
and 15.217.
Okay.
And then the 4 types of confidence intervals listed below, which one is appropriate for the situation? Okay, so I said for that, I said confidence interval for the difference of means using independent samples, because they're looking for a difference and the samples are independent of each other. So number 18, or sorry, number whatever you're on.
The Hummers from LA and New York?
Input the lower bound.
Right.
Hold on. Okay, it's number 18. C. So that was, the lower bound was negative 423.
And the upper?
Was 5,417.
Okay.
And then exercise bone density.
All right.
I said that the correct hypothesis was
Would that be
B
paired?
was ANOVA, because there's 3. You have to test 3 different things.
Good.
And then you calculate the test statistics. Is that the next question?
Uh-huh.
Okay, that was 7.978. So I just put this all in the spreadsheet.
Right.
And then give the p-value, that was 0.002. And then which of the following best expresses the conclusion of this test? And I said there is sufficient evidence to conclude that the bone density of at least one of the groups is different than the bone density of at least one of the other groups. See that as an option?
Yeah, I think so. Okay.
And then the direct flight costs. Calculate the test statistic. Do you see that?
Yeah.
Okay, that was 1.685. And the p-value was 0.096. And which of the following best expresses the conclusion of this test? For the level of significance, that was reject D. There is insufficient evidence to conclude that there is a difference. Sorry, I don't know if that's D for you, but for me, there is insufficient evidence to conclude there's a difference in the cost of tickets purchased 14 days compared to 90 days in advance.
Okay.
Okay, so I hope that's helpful. I have to run. anyway, we can text each other about the other if there's, if we have questions about the other.
Okay, yeah,
ones.
I'll run
Sound
these
good?
through Excel to double check everything. Thanks so much, and
Okay,
have a good
thank
one.
you. All right,
Yeah,
you too.
bye.